Let's see how we can use radian angle measure in an applied context. Suppose Laura is skiing along a circular ski trail that has a radius of 1.4 kilometers, and Laura starts at the 3 o'clock position. We should always start a word problem by visualizing the situation. So let's draw a quick sketch. So Laura's skiing on a circular ski trail, and the ski trail has a radius of 1.4 kilometers. We know that Laura starts at the 3 o'clock position. Now, suppose Laura travels 0.8 kilometers in the counterclockwise direction before stopping. How many radians did Laura sweep out? Let's start by drawing a sketch. So we've got the ski trail that she's on. It's got a radius of 1.4 kilometers. Now we know she starts at the 3 o'clock position, and then she sweeps out about 0.8 kilometers. So let me draw that. She sweeps out 0.8 kilometers before coming to a stop. We can visualize the angle that she swept out, so let's draw in some rays. So our initial ray pointing in the 3 o'clock, and then our terminal ray passing through that point where she stops. And we want to know what the measure of this angle is. That will tell us how many radians she swept out. So if we're trying to find the radian measure of this angle, we're trying to find the measure of the subtended arc in units of the radius of the circle. We know that she traveled 0.8 kilometers. So if we measure that arc with a length of 0.8 kilometers in units of the radius, which is 1.4 kilometers long, the measurement will be 0.8 divided by 1.4. And this has a value of approximately 0.571. So the number of radians that Laura swept out is about 0.571. So 0.571 radians. Now also this number is positive because she swept that out in the counterclockwise direction. Now, let's suppose Laura sweeps out from her starting position a 2.2 radians. And we want to know how far Laura has traveled. So again, let's start by drawing a diagram. We've got the circular ski trail, radius of 1.4 kilometers. She starts the 3 o'clock position right here, and then she sweeps out 2.2 radians. So 2.2 radians is something like that. So she sweeps out that 2.2 radians and she ends up here. So she travels some distance along the circular ski trail. So I'll mark this here in red. We want to know how far she traveled, which means we're looking for the length of the subtended arc. Now we know she swept out 2.2 radians, and the radius of the ski trail is 1.4 kilometers. So the subtended arc that she swept out is 2.2 times as large as the radius, which is 1.4 kilometers. So the number of kilometers that she swept out is 2.2 times 1.4, which is equal to 3.08. So she swept out 3.08 kilometers along the circular ski trail. Let's consider one last scenario. Laura travels 0.5 kilometers in the clockwise direction. We want to know how many radians she swept out. So again, start by drawing a diagram. Circular ski trail with a radius of 1.4 kilometers. Laura starts at the 3 o'clock position, but now she travels in the clockwise direction. She travels for 0.5 kilometers. So she travels 0.5 kilometers around there, and she stops after traveling that distance. Now again, we can visualize the angle that she swept out, something like this. We want to know the measure of that angle. We know that she swept out 0.5 kilometers along the circle, and therefore the distance that she traveled, or the subtended arc, is 0.5 divided by 1.4 times as large as the radius. So the measure of that subtended arc in units of the radius is 0.5 divided by 1.4, which is approximately 0.357. Now we have to be a little careful here. She traveled in the clockwise direction, and therefore this angle opens up in the clockwise direction, and angles opening up in the clockwise direction have negative measures. So the measure of this angle is actually approximately negative 0.357 radians. So it's not necessarily the 0.357. We need to add the negative to it because it's swept out in the clockwise direction.